Assalamu alaikum wa rahmatullahi wa barakatuh. Alhamdulillah. My name is Khalid bin Muhammad Ariff from Sekitar Synergy, Sindira and Berhad. It's me again. Today I live until this day of the 10th Rabiul Awal 1442, 27th of October 2020. And in this video, I would like to discuss and display an activity quite well known to all metal fabricators pertaining to sandblasting. And in this video, we will take a look how safety, health, and environment is related to this activity. What are the concerns of safety, health, and environment? Nonetheless, I will go a bit deeper for the environmental management because I am an environmental trainer. I've been in the field of applied environmental management since 1985, 84, 85. So I do learn from safety health experts. So I would leave safety health to the expert, the luxury of expert opinion of those who are well versed in these areas. So before we go on, I would like to remind myself and all other Muslims counterparts, please do not watch this video if you are already in a mosque for the Friday prayers, especially when the khatib is about to recite the khutbah, or you are in any religious sessions where you've got ulama or ustaz delivering lessons from the Al-Quran and all the other books. Okay, so let us go on and take a look of this activity. Oh, by the way, sorry. Thank you very much, YouTube. Thank you very much, all subscribers and viewers. Please do support orang tua ni, subscribe lah pada channel ini. And I thank you for your time and attention. Let's go into what we are going to discuss today. What we have here is an old picture when I was training a few personnel, in fact experts from the oil and gas industries pertaining to the offshore oil rigs, and this activity was ongoing, which is sandblasting. They have to remove all those contaminants, all those dirt from the surface of, they call it oil rig columns. Okay, and we will take a look how it was done, and it was in fact highly influenced by the weather conditions, because some of this activity was done while with the worker from a scissor lift from a boat if the water is still, and that is only towards the bottom part of the column. Those from the higher column level, I saw them using suspended platform. Okay, so let's take a look. So this column, over a period of time, with the interaction of marine water, which is actually rich with nutrients, a lot of salts as it is salty, and all this would promote growth of certain organisms at the surface of all these columns, they call it, and creatures or growth like barnacles, if I'm not mistaken, that's the term, would be quite thick over some time, and it could be just months. And these organisms would somehow cling on this column civil structure. In this case, is, if I'm not mistaken, spindle kind of a concrete, which is on the rig columns, which the rig column is composed of, and over time there will be an interaction between these creatures and the surface of the column. In other words, eventually it would lead to the thinning of all this column structure, and that would eventually lead to a compromise of the strength of the column, and that is a safety issue. Okay, so contractors are called in to perform this sandblasting, and when we were doing our visit, they were using some form of a copper grit shot from a blasting gun at a high speed, enough to remove the very sticky, well bonded barnacles on the surface of this column, and in that manner has aggravated the emission of dust like particles, not just spent copper grit, but also some concrete and sandy dust. So the environmental aspect that we are going to discuss is this spent copper grit. And by virtue of this work, how does spent copper grit affect a worker? We'll take a look in this direction. Apparently, in terms of safety, how does copper grit affect safety? Those workers has got to wear PPE to cover their face and to cover their noses and also mouth, and prevent from inhaling any of this dust. Therefore, the safety issue here, the potential hazard here is the blasting dust itself. And yeah, when they were working, we were asked to maintain a minimum distance from the working area while I take this photo, and we saw some coarse particles of copper grit and all these what they call remnants from the column sprang all over the places, and another potential hazard is the flying debris of that sandblasting work. And other than that, it's got nothing to do with spent copper grit. This is more of a potential hazard in terms of safety, is that some of the columns, we saw about two suspended platform being used, and this is a potential hazard as far as safety is concerned. And for my honorable fellow trainers, consultants in the health safety, please apologize if I said something wrong. I'm not the expert here, and definitely my knowledge would not match of those of yours in terms of health safety. Please add on in the comment if you know there are a few other things, more crucial information that you need to share with people so that they benefit from your knowledge. And now, as far as that is concerned, with that blasting blast as a potential hazard, what happens next is the risk, health risk, potential risk. And of course, when you're working with blasting dust particle all over the place, you may have some respiratory deficiency, perhaps some reduced movement, discomfort, respiration, and you, of course, you won't feel comfortable at all, and you might end up having injury, especially from the flying copper grit blast debris that could hurt people. Okay, can cause injury. And of course, all this is related to potential risk and how health when a worker is working in such a discomfort manner and would pose some problems. And when accidents happen, there will be what you call an environmental impact. All this copper grit might be spilled in the marine area, or the instruments, the mechanism might be, thrown overboard due to accidents and all this, and causing marine pollution, because when we are not fit to work, we might not be able to produce the correct work, and we might not be doing the work correctly, and that would cause the generation of environmental aspect from that, and would cause environmental impact to the marine water. It works vice versa. So that is how she work in oil rig, and it's no redundancy. It's just that matters like copper grit is an environmental aspect that shall be managed with environmental management technique. It also appear here, flying blast debris, which is copper grit, including copper grit. It's not, well, you can say it's redundant, but this shall be managed in a different manner. It is an environmental aspect in environmental management, but it is a potential hazard in safety. So it can be the same thing, but managed differently. So it's not redundant. It's just a matter of environmental aspect is universal. So it's a term, environmental aspect. In fact, PPE used here is environmental aspect. The platform is environmental aspect. Okay, the boat, the scissor lift, if any, and everything. All these equipments are environmental aspects. So environmental management encompasses the entire safety and health. So safety and health is rather specific, and it's tailored to ensure safe working order for human workers. Okay, now let's take a look into the environmental management. I hope you are okay with this, and please add in. I wouldn't want to make it so long or add in more, because the slide has a limited space, and I don't want to make this video for too long. I want viewers, especially students, academicians who are, wanting to know about this, and newbies in industrial practices to understand. If you're able to understand early, you are able to perform a good job earlier, and it's good for the company. Now let's take a look at the spent copper grit. Let us discuss this. Okay. Okay. Welcome to Environmental Management ISO 14001 version 2015. Okay. Well, I'm an old school in this. Now, let us discuss spent copper grit. It is an environmental aspect. Next question. Is it an input environmental aspect or output? Remember, spent copper grit. It comes from copper grit. Copper grit is the input to this activity. Once it is being used, it becomes spent copper grit that fly off from the impact to the column as a flying blast debris. So it contains not only spent copper grit, but also other associated debris from that blasting. Okay, now spent copper grit is an output aspect. See that? So when it is an output aspect and we want to associate it with its associated environmental impact, we need to look at the life cycle perspective of copper grid itself. What happened to copper grid? That will be the question. Output. Spent copper grid. What happened to it? Is it collected? Is it collected in a barge? Or is it blown off and que sera, sera? Whatever will be, will be. Is that the case? What happened? It will be flying until it becomes of fallout, okay, and landed onto the marine surface, marine water, and it will eventually sink to the bottom of the seabed. So that will be what? Upstream or downstream? That is the downstream life cycle perspective of copper grid as spent copper grid. And what does it cause? Initially, air pollution. Do you see that? It's in the air. It contaminates the air. Just look at the picture. I wasn't able to take underwater picture because I didn't bring my Nikonos 5 that day. And we were not allowed to get near. This picture is easily 25 meter away distant from the working area. That's the minimum. We have breached. In fact, we are supposed to stay about 50 meters, but we came in nearer because I wanted to take the picture. And what happened to the spent copper grid? It will contaminate the marine water. What happened? It will float, suspended for a while over certain layers of marine water as it sinks to the bottom. It would contaminate the zooplankton. It might be eaten up by smaller fishes and other aquatic lives as it gets to the water, and it might get into the tissues of some of the aquatic proteins that we consume as fish. Okay, and eventually it will settle down at the benthos area, the seabed itself, and the presence of copper grid is not welcome as nutrient. For the benthos community, what happened? The benthos shall be deprived of gas exchanges, shall be deprived of nutrients, and might have some other abiotic changes, pH, acidity, some other compounds might develop and not at all suitable for the growth of the benthos community. So eventually the benthos, including corals, would be extinct. Okay, and it happened. Now that is spent copper grid. Now let's look otherwise, the opposite end, the other line of the LCP. Let's talk about fresh copper grid. Where does it come from? We have to know whether this is input copper grid or not for every environmental aspect. In order for us to find what is their relative, related or associated environmental aspect, environmental impact, we must know whether it is an input aspect or output. If it is an input aspect, we shall look at the upstream of its life cycle. Then it is called life cycle perspective. We look at that substance, that environmental aspect, that particular matter upstream, because it is fresh. How do you know that? Because it is an input aspect. So where does copper grid come from? Of course, it comes from copper grid fabricator, manufacturer of copper grids. Where does it come from? It comes from ore. Okay, maybe initially it might come from a smelter that gets copper, and copper is then macerated into pieces. Okay, it could be in molten copper and passes through some kind of extrusion, and it might be cut off into copper grid. Where does it come from? Metal ore, smelter, and then from metal ore. Where does the metal ore come from? The ore comes from excavation of rock structures of the earth, where you have all types of metals, so they will separate copper from the rest, and that's the origin. And what is the environmental impact from mining those metals? Take a look. Resource depletion. And when we blast hills, rocky mountain, we blast rock structure of the earth mesosphere, we are actually compromising the strength which is already in existence for millions of years. We blast them, we create man-made fractures, ruptures, and has led to a deviated groundwater direction, and all this and the rest. You can check it out with experts, geological experts, and other environmentalists who can give you a thorough insight of what happened to the geological structure if we tap it just for resources. So the copper grid, fresh copper grid, as an input environmental aspect, has an associated environmental impact that would be that of resource depletion, which is quite common, known to all. But personally, I would rather get into the permanent damage, which is geological damage or distorted geological structure. It could be another version of environmental aspect in this manner. So all these machines uses fuel as well. Let's take a look at this aspect. And this is also an input aspect. So looking at it from its life cycle perspective, since it is an input aspect, we look at the upstream of its life cycle perspective of its life cycle. So it causes an environmental impact, which is resource depletion, because the more fuel, diesel in this case, is needed, the more the oil and gas refinery would have to extract diesel, and the more crude oil will be excavated by rigs like this one, and the natural resource will be reduced time over time. Okay, and the impact is called resource depletion. And of course, when we drill in the bedrock, it has caused a substantial amount of geological damage, because there's a cavity at the bottom of our bedrock where the fossil fuel lies in the form of rock. Okay, and normally it's being filled up. Now the practice is it is being filled up with mud, because crude oil is brought up, separated from, the drill mud is brought up, separated mud and crude oil. The mud will be returned back to the cavity, and the mud has got different strength, different thickness as compared to a solid rock structure which contains fossil fuel initially. Different strength, so it would be a permanent damage to our geological structure. So that will be or an interest in environmental management if you're doing ISO 14001 environmental aspects impact register. Okay, let's go to the next phase of environmental management system, whereby in this definition of environmental management system is to manage environmental aspect by obligation to compliance obligation, and to address risk and opportunities. That's, I think, the definition of EMS. Check it out in the standard. Now let's take a look at risk and opportunity. We are now in EMS, all right? So how do we manage spent copper grid? Okay, and the risk associated to spent copper grid is legal liability. Where I'm from today in Malaysia, spent copper grid is a scheduled waste. Okay, and it has got to be brought back to inland somehow, knowing this activity, and there is a liability there on schedule risk regulation. All right, I don't want to talk about legal too much. And there is another risk. For me, this is more important because copper is itself a valuable metal. If I'm the stakeholder or board or of directors of this company, I would try to find out how can we recover copper, because these are all environmental resources, and copper is a metal with associated market value. Okay, and we would like to find a way whether we could use this or perhaps recover, collect, contain. Otherwise, I might as well use some other kind of blasting agent like silica or perhaps garnets, so that I do not waste copper. Okay, that's another option. And there is another risk here due to the activity, and actually this is more on safety. I wouldn't like to cover it here. If you are doing ISO 14001, do not include reduced column integrity as one of the environmental risks. I'm just giving an example here, the mistake that we can make, especially when we are as HO, safety health officer, safety health manager, come schedule with competent person, come environmental management representative, come accounts head. We might be looking at all this and eventually get ourselves mixed up. So this is one of the error done by many. They put in things like reduced column integrity. Let this be managed here and here. Okay, let it be addressed under health and safety. They will come up with health and safety opportunity for improvement. Okay, try not to address this in environmental management system. And let's take a look at opportunity for this activity. Apparently, we have got to do blasting because of the barnacles, because of those growth. Okay, marine life growing the surface of the column, and there are research going out on that they have developed some kind of paint which is anti all these marine creatures. I have seen about 7 of them, and I've gone through the SDS. Apparently, most of these paints are acrylate base, acrylic acid literally, and from my understanding it is really carcinogenic. But if it is done carefully, the coating is done well, we can have another coat over this carcinogenic paint, so that not only it can withstand marine abrasiveness and demote or prevent growth of marine lives, marine like barnacles and the other creatures. It should also be safe to the marine water when it is cured over the columns. All right, so research needs to be done, and I have seen from theses that I bought online that even though they are cured over time, the abrasiveness of marine water, the waves, and all other physical factors eventually, and also heat changes, eventually crack these paint surfaces, and thereby exposing, this paint to be contaminating the marine water. That's what I saw so far. But you have got something new, please write down in the column. It is an interesting thing for us to learn. So this is one opportunity which is actually affecting marine water pollution. So we have done this far, and why not you work out yourself the effect of environment to health in this way, like spent copper grit. How does it affect health? Can you do that? And how health would affect safety? I think that's quite simple, isn't it? And how does the safety potential hazard causes an impact to the environment? Not so tough. So it is interacting these three elements, important element in any activity: health, safety, and environment. So I hope we have had enough. Is it? I hope we had enough. I hope you are able to understand how to determine environmental impact from an identified environmental aspect. Remember to look whether it is an output or input. If it is an output aspect, go to downstream of its LCP, life cycle perspective. Thank you very much for your attention. This is the best I could do for this half an hour, I think. So I don't want to make this video too long. Thank you for your attention. Thank you for your time. Thank you, YouTube. And I wish everybody in bahasa semoga dikurniakan kesenangan, keselamatan, kesejahteraan, dan kebahagiaan. Kehidupan di dunia dan di akhirat is my wish for everybody. And I end with the biggest wish of all. Assalamualaikum warahmatullahi wabarakatuh. See you in the next video, inshallah.